Okay, this is where I had left off. Now let me go ahead and separate the parts that I've done so far. So I had gone ahead and separated my dy over dx. I've integrated both sides and made a u statement and replaced my values. So now I'm ready to find my solution, which I'm going to have to integrate. This would be u to the negative 1/2 du. So that's going to give me the answer of 10/3. And then I'd raise this by 1 and put it over that power, and I'd have plus c. Well, that gives me 20/3 the square root of u plus c. Now remember, we're not supposed to leave it in terms of u, so we're going to substitute our u value back in, which was this 1 plus x cubed. So our final answer would be y equals 20/3 the square root of 1 plus x cubed plus c. In this next problem, we're going to solve another differential equation, so I'll go ahead and start by moving my dy to the other side, or my dx to the other side, excuse me. I know this requires substitution because I don't know how to integrate something with a fraction, so I'm going to make my u what's underneath this square root, x squared minus 8x plus 1. So when I take the derivative, I get 2x minus 8 dx. Now, if you start to look at what you have, you need an x minus 4. Well, I can actually see an x minus 4 here if I just do some factoring. So what I actually want to go ahead and do is I want to rewrite this now because I was integrating both sides. So the integral of dy would be y. And the integral here, well, I haven't integrated it yet. I need to go ahead and rewrite this. So it would be the square root of u. That takes care of this part. I need an x minus 4 dx. That's right here. So I need to move my 2 over and make it a 1/2 du is equal to this x minus 4 dx. So I'm going to put my 1/2 out front, like I always like to do, and my du here, which means there's just a 1 sitting here. So what I really have is I have the integral of u to the negative 1/2. So I can now take the integral of this, which would be u to the 1/2 over 1/2 plus c. 1/2 times 2 ends up giving me a 1, so really all I have is the square root of u plus c. And then last step, plug your x's back in. So your the answer to this differential equation would be the square root of x squared minus 8x plus 1 plus c. Last example, it's asking me to sketch 2 approximate solutions of the differential equation, and I can actually show you that in class. We're supposed to use the slope field, and I can't create that on here, so I'm going to leave that for class. We're going to use the integration to find a particular solution of the differential equation. So in order to do that, we actually need to solve this differential equation, and it does require u substitution. So my u statement is going to be x cubed minus 1. So du ends up being 3x squared dx. I'm going to replace then, because I'm integrating both sides, this ends up being y. Y equals, I would have my u taken care of by writing u squared and then adding the x squared dx, which I have, as long as I move my 3 to the other side. So I end up getting 1/3 du. So now I can take the integral of this, which gives me 1/3 from the 1/3 out front, u to the 3rd over 3 plus c. So I get y equals 1/9 u to the 3rd plus c. Now we're actually supposed to find the particular solution to this, which means I'm going to be using this value for y and x. So coming over here to the side, I will substitute 0 in for y, and I will substitute the 1 in for x. But I need to go back here and make a quick correction, so I forgot to put my x back in. My x, when I put that back in, is x cubed minus 1 plus c. So now I'll go ahead, I'll make this y, and so I have 0 equals, and I'll plug in 1. Well, that ends up giving me 0. So my c value is 0. So my actual solution would just be this portion, because I'd have 0.